I meant to do the marking over the weekend. That unfortunately didn't happen. So yeah, so it was a mission not accomplished. So I apologize, and I'll try to get it as soon as possible this week. Okay.
So are you happy with the P3?
Happy with what?
Happy for the P3?
For the P's? Wait, what? For what? I didn't
The
understand.
Australia,
Is that if I'm happy with the result?
the P3. Leclerc.
Oh, the race. Yeah. I think it was okay. Like, I mean, it was good.
I wonder how much cheating happened this year.
Yeah, but but it was exciting at the beginning. Actually, it was
Oh.
pretty cool.
Are you going to Shanghai this weekend?
That's
Yeah,
too
the
far
Chinese
away.
Grand Prix.
Okay, Gabe is coming.
Yeah, no, I'm probably gonna go to Montreal maybe. Yeah, don't know how things go. Because I thought Miami, but that's too soon. So maybe Montreal will be better. Okay, yeah. So the exams, like I said, hopefully soon this week. And then I know Carl was asking me. I did not reply, but I did post here the assignment 5 and lab 1. They're not on Brightspace yet, but they're here. So I'm gonna quickly go over assignment 5 first. Assignment 5 is the user part 2. There are a couple of things that you need to complete here. Not a big deal, but we should do that before we continue with the club. Okay? I'm gonna go over that first. So these two functions that we have here, I think we already have implemented, right? One is the transmit string, we've been using already, and the other one is the TX buffer. I don't know if that one we've talked about, but the difference between the two is like the TX buffer, instead of the TX string, because the TX string, what it does, it transmits until it finds a null character, right? So that's kind of the philosophy. Whereas this one, it will transmit until this many bytes, okay? You also pass an array start to it, but it's only going to transmit whatever you pass in there inside. Let's say if you pass a 5, it's going to transmit 5 bytes. So you should do this in a for loop where you count and up to this number, okay? Why would you want to do that? Well, now it's a little bit hard to understand the usage of that, but what is going to happen is that in the future, we're going to transmit packets that are not necessarily just text, okay? So when we're transmitting any type of bytes, we need to know exactly how many bytes we are transmitting, because looking for the null character doesn't work in this particular case, which is why we need this. Okay? Now, the escape sequences. The escape sequences is something that has existed for a while, and in order to use these escape sequences, we need to use a specific terminal. So we need to use either TeraTerm or a PuTTY, okay? So not every terminal supports escape sequences. So if we use the open source terminal, that one won't support them. Now, how do the escape sequences work? Well, first of all, when we transmit a backslash, that means a special character. A character that is maybe non-printable. For example, when we transmit \r, we're transmitting a carriage return, right? When we transmit \n, we're transmitting a new line. When we're transmitting \o, or 0, sorry, we're transmitting a null character, okay? So anything that starts with a backslash is a special character. So in particular, these ones at the beginning are all special characters. Now, what does the X mean? The X means hexadecimal. So in reality, what I'm transmitting here is this byte. Is the hex byte 1B. Okay? So if you ever want to transmit something in hexadecimal, you will do it like this. So that way you could transmit characters that are non-printable. Okay?
So is the transmission specifically happening because we're indicating that it's a 1 here? Or it's just 1B?
1B is a special character that we use it.
Gotcha, okay.
Yeah, for this particular escape sequence. And then they're followed by regular characters. So this one is a square bracket, then a 0, and then a K. But those are text. It's just the first character that is X1B. Okay? So if you wanted to transmit 2 hexadecimal characters, it will have to be X1B and X something else, right? So you have to keep having the X. So in this particular case, it's just that one that's hexadecimal, and the following are text. Now, the whole list for the escape sequences is here. So if you click on this one, if you go to the TeraTerm website, you will see the entire list of this thing, which is huge. Okay? But again, I don't want to give a lot of emphasis to this because this is more like hobby, interesting, fun stuff. But I find that it's little application of this in the real world.
I'm sorry, it's just a little loud. I can't really hear the lecture.
Yeah, and guys on the back, please try to keep it low because we can hear you talking. All right? Yeah. I'm already getting distracted as well, so try to keep it. Darine and JP, please lower it. Okay. All right. So there's little application on this, okay? But still there, so it's kind of fun to do it. Now the ones that we're going to be using the most are, for example, placing the cursor in one specific position, maybe clearing the entire screen, okay? That one I had trouble finding before. Erase the complete display. So if I send this whole thing, that will clear the entire display, okay? And this one will go to the position 0, 0. And obviously, if I wanted to go to position 25, 25, I can change the 0 with a 25, and that will move the cursor there. Again, for these to work, it has to be TeraTerm or Pi, okay? It cannot be any terminal, or any other terminal that does support this escape sequence. In the past, this used to be used a lot. Not anymore. That's why I'm saying that it's interesting, but not so much application for this. Because in reality, what you're gonna have is what Rex and I were just discussing before the class, right? You will have some sort of communication between two devices. You won't have a terminal where you want to change the color because this is not a console application, okay? But anyways, we'll test these things. There's also a way of changing the background color or the foreground color. And for that, we're going to add these functions, okay? Remember, you need prototypes for this function also to be placed in the .h file, and the .c will have the implementation. So we'll, of course, have the transmit string, the transmit buffer that I just mentioned before. And basically, we're going to focus in 3 functions. One to clear the screen, one to go to the position xy, and one to transmit a string in that position xy. Okay? So this one, we'll call this one first, and then we'll call that one. Okay? So inside here. That's basically how it works. In case you haven't seen, I noticed, I named this one starting with term, not with UART.
Because
I did that intentionally because these are not really UART functions. These are just more special functions for the terminal, okay? So it does not make sense to me to call them UART.
But they're communicating via UART, which is why they're in that line.
Yeah, yeah. That's why they're gonna be placed in the library, but they're more like terminal functions, okay? And the assignment is here, so all the specifications is in here. So I did a demo. The demo I did is called a term demo 1. Okay. And for example, I'm doing two things here. See, this particular sequence that I'm sending here sets the background to red. Why? Well, if we go here, this one says set the background to blue because it has a 44 here. And now all the colors are here. So I can replace this 44 with any other color. See, 44 is for blue. But then if I want to set it to red, I just change it with 41. To black, 40, which is the default. Which is why in this particular case, I'm setting the background to red. Let me just open this in Seger. Okay. Then the next one is erasing the entire display. If we go here, erase the complete display. So all you have to do is just copy these things and send them as a string. See, that's what I did. I placed this in here. It's a escape sequence. The reason why I needed to erase the entire display is because if I set the background to red, it's only going to set the part where I'm displaying something to red, and the rest is going to remain black. I'm going to show you what happens if I don't clear the screen. I'm going to comment out this. I forgot that I'm using this guy.
With the speed?
So this demo was taken from a previous demo. I'm just incrementing a counter every half a second, and I'm displaying it on the terminal. But the only thing that I'm doing different now is that before displaying the counter, instead of like scrolling down like before, remember, I'm gonna place the cursor at 1020. So that means that the counter is always going to display on the same position. So it's gonna override the same line, which is gonna be very, very useful. Let me just open Teraterm. And I'm connecting, I think, at 9600. So when I run this thing, see, it goes here. Now, I think I need to correct something in the notes because it says that the first, I always, you know, in graphics, we always get a bit messed up with this. I bet when you do GDI drawer, the same thing.
Yep.
Which one is the X and which one is the Y? It says that the first one is the column, but it turns out it's not. Well, if the 10 is the, let me just change this. Let's change it to 020. So if I do 020, it should be column 0, row 20, right?
It should be XY.
So the Y is
Should be 20.
the row
Zero.
or the column?
Your 0 should be X.
See, it's displayed on the top there. Does that make sense or not?
No, because that means that your Y value is first and then your X value comes after.
Yeah, so
Why?
it's just a matter of semantics, I
Okay.
guess. So I'm doing 020, right? So 0 means, yeah, so this is kind of backwards.
Yeah, so 0 would be 0 of Y, whereas 20 is 20 pixels over to the right.
Yeah, so we have to look at the notes to kind of figure that out better, I guess. Well, anyways, it just works like that. It does not really matter much, to be honest. What we're more interested in is just being in one specific position, okay? Which is why I made this one 1020. I think the H is the height. No, it's not, because then it would be displaying different. Okay. But I want to show you this. I'm going to open Teraterm again. And now it's displaying in black. Why? Because the background change happens at the beginning, right?
And you've
And since
cleared
the program is
buffer.
already running, see, this thing is not a console application. This is what I'm trying to hopefully make you,
Well, 'cause
keep
we
in your
changed the-
brains that these are just commands.
Because you changed the color before we hit our infinite loop, and if it's not inside the infinite loop, you clear that buffer. It only sees what's intertwined.
Yeah, and this is a command that TerraTerms receives and then interprets, and then it changes the background. See, but it's only changing the background of that, which is why at the beginning here I was also sending a clear screen command, so you can actually clear the entire screen. That way, the entire screen will become red. Okay. Now, am I going to ask you to do something like this on the exam? No.
Well, maybe.
The only thing I will probably require in the assignments and maybe the exam is to be able to display on the same spot, because that's convenient. Like if you want to display multiple things, you might want to display something here and maybe something on the next line and just keep updating both. As opposed to having something scrolling, we want to have something fixed to the screen. Okay, that's the only really useful thing that we can get out of this. Carl seems very confused. Questions?
Let's see the code again.
The code?
Yeah, I assume you're working on this locally. It hasn't been pushed to the repo yet.
Yeah, I haven't pushed the repo, but
Okay.
but again, if you go to the assignments,
Yeah.
all the information, all the relevant information is here. So what you need to do after this class is to play with these things, maybe change the colors. You can also change the foreground color, see, with this command. Well, the foreground colors are here. See, I think the 30 ones, because all of them would change either the foreground or the background. I think the background starts at 40, so anywhere between 30 and something would change the color for the foreground. Okay? And you can also use RGB colors if you want to with this other particular. But again, do the assignment, but play with this if you have energy and you find it fun. But to me, this is, yeah, what can I say? It's not really useful. Sorry to say, but I see very little application in this. Yet the instructors have kept this thing for many years. Even in the past, they have like a large assignment that you have to change the colors.
Well,
Why?
learning escape sequences is important for other things.
Well, maybe, yeah. Such as?
I don't know yet.
Yeah. Yeah. See, well, maybe things that are no longer used, I guess. But, anyways, it's there. The assignment is there. Then after that, after we do assignment 5, we should work on lab 1. In lab 1, you will have to connect the button board to the development board. 2 LEDs and 2 buttons. I specify exactly what you need to connect. Switch 1 to PD8, switch 2 to PD9, and LED 1 or diode 1 to PC4 and diode 2 to PC5. You also need to connect the ground and the VCC pins like I showed you, or I didn't show you.
I mean, ground is there, and we hopefully understand what VCC means at this point.
Okay, so what you need to do in this case, let's say that you're very confused about this thing. Who is very confused about this? Be honest, can I see hands? Yeah, I have at least one student, 2, 3 who are very confused. So what you need to do, you need to go to important resources, in case you're very confused, and you look for the HC35S button board. You open this thing, and you gotta thank Simon for making this schematic. Because this schematic that they had on AliExpress where we bought this button board was awful, the resolution was awful. So Simon went and created a new schematic for this. See? The keypad matrix, which are the top 16 buttons, we're not really going to use those yet. We're going to focus on using these buttons. So the key B connector that is labeled key B is the one in the middle. That is the one that has all these pins, okay? So you're going to connect this one here to the ground of the micro and this one to VCC, and the switches are labeled here from switch 1, 2, 3, and 4. Okay?
That's as S1 through S4?
Yeah. And the diodes, or the LEDs, well, LEDs are diodes, are labeled here from D1, D2, 3, 4, all the way up to D8. So I'm asking you to connect the first two. Okay? This one also has a VCC pin. I believe this one doesn't need to be connected because that's already internally the board is shorting this VCC with this other one. So only one VCC needs to be connected. I think I did a couple of demos with this, right? When I was doing the counter and the display, right? Or one demo at least. Yeah. This is going to give you an opportunity to play with this button board and make things work.
Is debouncing something we'll have to take into consideration when doing this? Like a proper debounce?
We're going to talk about debouncing maybe later. For now, I wouldn't worry too much about it. Yeah.
Will we use this on the next exam?
Yes.
Yes.
Most likely, yes. Which is why, yeah. So please make provision because in 2250, I'm having the same issue. I have students that don't have jumper wires. So supposedly you have in your kit somewhere. So if you don't have, you need most likely female to female. If you don't have, what do you need to do? Buy something. Exactly. You could ask someone to do it. I could maybe put an order if you want me to do it, but you need to let me know in advance. So we cannot be dealing with this the day of the exam. Because I've given a lot of this ones away already, since I don't have. And I don't have any more, right? So I cannot really help. So I'm giving you enough notice. Our exam is probably in 4 weeks or so. So get your jumper wires. Get someone to purchase a whole bunch maybe, and then distribute to, if you don't have. But you maybe need around 8 to 10 of this. And hopefully a red and a black to use the VCC in the ground, right? The other ones can be different colors. Any questions about this? So I guess when you go through the lab and stuff, you will have more clarity, right? And in terms of if you have any questions. But basically you're gonna have rendering the switch states here. So you're gonna have to use the state variables that we're talking about and the two LEDs in here. I'm also asking you to use a data struct to keep track of the pin and the port so you can actually update those accordingly. And the last part, it's asking you a bit more. All right, so those are there. I'm gonna add them to Brightspace and add the due dates to them as soon as possible, but they're already there for you to start working on, okay? So you have a couple of things to work on right now. All right, any questions? No?
Not until we start writing code and figuring and trying to find out why it doesn't work.
Termscape sequences is 21. I think I missed a. Okay. We're going to continue with the clock system. Oh, somebody's trying to get in? All right, so one way to look at the clock system is to look at, create a project in CubeMX, right? And then look at the clock configuration. The default configuration is going to be this. So by default, our system is running at 16 megahertz because it's connected to the HSI, which stands for high speed internal. So if you follow this trace all the way to here, it goes to this guy, which is 16 megahertz. If we were selecting the HSE, which is high speed external, then the system will connect to this one here and it will run at 8 megahertz. Okay? We're not really going to do much with that one directly. We're mainly going to focus on using the PLL. Okay? and set everything back to default. So HSI is 16, and when we use a PLL, things will change accordingly. PLL stands for phase lock loop. Okay? The ones that are interested in digging deeper into the theory related to what a PLL is, in the clock section, is this our section? No, it's not. I think I also exposed the material for this section as well. If you go to the content, and then you go to clock PLL, so the header for the clock is here, the .h file. We're gonna go through it very soon. But there's a link that says phase lock loop. So you can take a look at this. Remember that when I talk about the PLL, I basically said that it's a frequency multiplier. I don't expect you to understand all this because these are diagrams, and that f of s is actually Laplace, and those things you guys will learn later. Yeah, so this is a closed loop, way beyond the scope of this course. But if you're curious enough, you can look at this, and it explains a little bit how this works. Okay? Okay, so I'm going to put the lesson here on this side. Clock system. Remember, we talk about all these oscillators, right? The HSI, HSC, LSI, blah, blah, blah. We talked about the clock tree. It's the same thing that we're displaying in CubeMX. We gave an example. We talked about how to verify the clock speed. We can use the CMC's function, but we could also do the MCO output, okay, which is what we did last Friday, right? Or not? Who was here last Friday?
I remember going to the exam last Friday.
The exam wasn't on Friday. It was
That
on
was
Wednesday.
the answer.
Yeah, we went through the answers Friday.
And then
That's
we had
it?
like 10 minutes to go through stuff.
Oh.
And then
Okay.
you said we would look at more of the stuff on
Okay.
Monday.
Okay. Yeah, maybe I should go through this. See, yeah, that's the part. Maybe I did that with the other section. Okay, but we have one way of knowing by using this method, right? That we've been already using, the system core clock variable, right? We did talk about that one in the past. We said that that variable gets updated in the background for us, blah, blah. I don't see a lot of confirmation. Let's just open that demo.
The demo.
So that would be a demo, speed demo one, yeah. Demo 19. Yeah, this system core clock variable is defined in here, right? And we did talk about this thing that it has these functions, the system core clock updates, whatever, that updates that variable in the background for you. So when you create these PLL functions, you will have to call this function to actually update the variable, so it actually keeps it consistent. But for now, we know that this variable holds the value of the clock. How does this variable get updated in the background? Well, it starts by default at 16 million, but it also gets called in the startup function. Did we talk about this assembly thing?
I don't think so.
Yeah.
Very early on.
This assembly file gets called in the background before the program jumps into main. And it executes all these things that are very nonsense and hard to understand. But at some point, it writes a value here, see? And it calls this function, system core clock updates. It's just using assembly language. Any idea why is this written in assembly?
Well, it's computer language.
But why would they write this
More efficient.
startup function, a startup file in assembly?
Efficiency.
Efficiency. Excellent. In fact, there's a funny story. I told the other section, but I don't know if I told you guys. There was a post on, I think it was on Stack Overflow, somewhere a guy said, hey, he wanted to show off that he understood assembly. So he said, you know what? I took this file for the STM32 and I wrote it in C and it does the same and it's beautiful. And then somebody said, well, that's nice, but it defeats the purpose. They wrote this in assembly for a reason, right? That's why, otherwise they would have given this in C. This is super efficient and quick, and it runs in the background before our program jumps into main. So when we jump into main, we already have certain things configured, like the system core clock update was called, and our function, our variable, sorry, already knows what is the speed. That's why we can use this. But aside from that, we have a second way of checking our clock speed. And the second way is setting the MCO out. And in order to do this, we need to configure an alternate function. Okay? And in particular, the alternate function for displaying the MCO out, MCO stands for master clock output. Okay? If we go to the data sheets, we go to pinouts, we try to find the alternate function for PA8, and we see that the alternate function 0 is MCO. We can also have it in PA9, either or. So I chose myself PA8. So I did call here alternate function. As you can see, alternate function 0 for PA8. Okay? That enables the MCO line. Okay? That is not enough though, because enabling the master clock output doesn't do the whole job. I need a couple more things to do. And that's also explained in here, but I think it's better to look at the code. So if we go to the reference manual, to this configuration register, we notice that there's an MCO select here. And it goes through this list. Are you guys sure I didn't go through this? No. I maybe went through this in the other section. So by default, this is 000. So by default, it's no clock. MCO output is disabled. So we need to enable something here.
Sysclock.
And we want to enable sysclock because we want to know our system clock. We could enable the HSI 16 to test it, for example. We could enable the PLL, the LSI, any oscillator. But in particular, we're going to use system clock. So we need to write a 1 on the bit 0 here of this location. So if you notice what I did here, I'm clearing first the setting with this mask. Note that this mask is bit shifted by 24. Because you saw that in the reference manual, the bits are in the 24 to 27, I believe, right? Bits 24 to 27. So that clears the mask first, and then sets the bit 0. So underscore 0 is the bit 0, so that means it's a 1. Bit shifted to the left by 24. Yeah?
CFGR.
Which one?
CFGR. We're pointing to this particular register. I'm just wondering what the register is.
Oh, it's the configuration register in the RCC.
Okay.
Yeah, it's where all these things happen. Yeah, this is part of the RCC. We've been using already the RCC to enable the
Yeah.
peripherals, right? Now we're digging deeper into the RCC because we're configuring the clock. So the first thing that we want to do is we want to have the clock outputs on a pin because we want to check it with the scope. And this is something I'm going to require you to do because you cannot set the clock to 40 megahertz and just hope that it's at 40 megahertz. Right? You have to verify it. And one way of verifying it, that every micro will have this, always a way of outputting the clock. So you can check it with a scope. Also, you can do it with the software, right? The first option, but still, that's just software, right? It's not really physical verification.
So best practice is to put the output on a pin just to
Yeah.
confirm that it is correct, and then you can continue.
Yeah.
Okay.
So then selecting the underscore zero will enable actually the sysclock. Okay? So right now, if I run this demo, I should be able to see the signal on that particular pin. So I'm going to bring it up here.
Oh, no way. Who put that screensaver on there?
Well, many instructors that are fans of Star Trek, including myself. But I also like Stargate. So, are we in agreement that we see a 60 megahertz signal?
Yes.
Yes.
It says they're good at quantify.
Except what?
Oh, I was just saying, it says they're good at quantify.
Yeah. It's not a. Would you expect a square signal or what?
No.
No.
No, because it's an oscillation. Most oscillations are represented as a sine wave.
Yeah, they're not really. And as you go faster in speed, it looks more ugly actually.
You could turn it in.
So
You wouldn't want a square wave for your.
what is going to happen? What is the maximum speed this micro can go up to?
64?
64 megahertz. Yeah, that's correct. Would we be able to see 64 megahertz on this scope? What do you think?
Yep. Well, hold on. Barely, but yeah.
Yeah, it's 70 megahertz, right? So we can still see it. Would you be able to see 64 megahertz on your analog discovery too?
Have to check the spec sheet.
Yeah, right? And I can tell you in advance that no. The analog discovery, I think you can go up to 24 megahertz, that's it.
So, this is a little slightly off topic, but like, what would the price point of an oscilloscope that can do, or that could read the maximum clock speed on our boards cost?
Yeah, so it depends a lot on the brand, but an oscilloscope that can go higher than 100 megahertz, an oscilloscope that can go to 100 megahertz, you're definitely talking over $1,000 just for a Chinese one. Even if it's a Siglent, which is a good Chinese, that's a good brand, that would cost $1,000, $1,200, $1,500, something like that.
Okay.
If you're thinking about a Tektronix, you're talking already
Tens
over
of
3,000 or
thousands.
4,000.
Yeah, oh,
And these guys are like in the middle, like 2,000 something. But these are not great, to be honest. If you are looking to buy a scope and you're willing to buy used, I would definitely recommend going with that Tektronix. Those are kind of the best ones in there.
What are like the price ranges?
Well, a used one you can get maybe for 700, 600.
that's not bad.
Yeah.
I mean, considering if you wanted something with 16 channels, you're looking at tens of thousands, like 40, 50, 60, 80 grand.
Yeah, the oscilloscopes are expensive, which is why your analog discovery, even though it's limited, is a good tool for the price, for 400 and something. So please do not sell it when you're done in school.
No, it's also a logic
Don't make
analyzer.
that, yeah, don't make that mistake. You could use it professionally. I've used it professionally.
You could reverse
Still works.
engineer with an 82.
Yeah. All right, so what do we do then? At home, I have a very humble D&K, I think it is the brand.
Yeah.
Those are very good too, but mine is only 25 megahertz. So I cannot really see 64. So what do I do?
Is there a trick?
Well, the micro manufacturers already thought about that, which is why here they have the MCO prescaler. So we can actually divide the MCO line, okay? And in this particular case, I'm gonna choose this one to divide it by 4. So I'm gonna say here,
If you're setting it to 60,
yeah, so I'm gonna see 4 megahertz instead of 16. Divide MCO line by 4. How do I do that? Well, I need to go to the RCC configuration register, and I need to clear first the RCC configuration register prescaler, MCO prescaler, not NCO2 because there's a second MCO, NCO prescaler. So the MCO prescaler has a bit shifting of, come on, show it. I think I need to type the whole thing.
So every time we clear that particular register specifically, we're essentially just setting it back to default before we set it up for the config that we're wanting.
Yeah.
Okay.
We want to clear as a good practice. This thing is not, oh, because it's running.
Oh, there you go.
Okay, so this one is bit shifted by 28. Yes, in fact, if we go to the prescaler, it's from bit 28 to 31. Okay, so now we want to prescale by 4, so we need to set the bit 1, 0, 1, right? So what I'm going to do is now, this is the part where we need to make sure that we master the bitwise operators. Divide by 4. So that means setting which bit? Bit 1, right? Which one is bit 1? The underscore 1. Because the underscore 0 is bit 0. So in fact, what this number is, represents, is what? It's a 2 bit shifted by 28. 2 in binary is 1, 0. So it's a 1 on the bit 1. So that works. If I run this, let's pay attention to that. 16 megahertz.
So that should drop to 15.
No, it should drop to 4.
Ah.
Because now we're dividing by 4.
Oh, because you haven't set the clock to something else yet. Okay.
Okay. Now, I want to be super clear here. The clock's still 16 megahertz. The clock is 16 megahertz.
It's
The
transformed.
4 megahertz that you see here is just the output. The output is being divided. So you can see it in a scope that is lower. Okay? The clock internally is still 16 megahertz.
Why is it more square?
That's lower.
Yeah, because lower. The slower you go, it will look more square. And it has to do with the sampling as well. Because one thing is the megahertz, the other one is the sampling. So 2 gigasamples per second.
It's a lot.
Still a lot, yeah. But out of one period of a signal that is 60 megahertz, for example, let's do the divisions. 2 gigasamples, so that means 2 exponent 9, right? Divided by 16 exponent 6.
So
It's
we
only
got
125 samples.
a second. Okay.
Now, if we divide by 4, it will be 4 times that, right? So now in this signal, we have 500 samples. So that's why it looks more square.
Gotcha. So if we were to increase the sample size, would that?
Yeah, if we will increase the sample rates, for sure it will look more like this. Remember, when you're doing this, when you're digitalizing a signal, you're actually getting a sample of the signal, but not the original signal. Okay? And yeah,
Okay.
I don't want to go further with that because then I'll start talking about MP3s and all that kind of stuff. Yeah, so it has to do with that. Okay? Any questions about this? Because it's important that we know how to verify. Okay?
So for instance, for our ICA specifically, if we're needing to set the clock signal to say 60, and then we wanted to divide by essentially whatever scope you're working with, you want to look at what it can handle and then see which division would get you
Yeah.
to a point where you can
Yeah.
read it on your scope.
And please take a look here. The way the prescaler is done is kind of weird. So this is counted in binary, 0, 1, 2, then the next one is 3.
Yeah.
But the 3 is not divided by 3, it will be divided by 8.
Eight. So that's
16, 32, and it goes all the way up to this number.
Yeah. So
Okay.
it's a power of 2.
It's a power of 2, yeah. Which is why, in my library that I already put on Brightspace, so if you go to the clock section of Brightspace, there's a clock PLL header already for you. and that one contains the clock.h. And as you can see, I have here an MCO division. See, 0 is divided by 1, and so on, all the way up to, well, I could have done 32, 64, but at this point I got bored, and I jumped to the 128.
Sure.
See? Values go 1, 0, 1, 2, 3, 4, see?
We
And
can
it's been
monitor.
shifted by 28, because that's where it's located. So
We can
that's
monitor.
already there to show you, to help you. And this, the MCO select as well. See, this is B24, and these are the enumerations for the different systems, so the sys clock is already here. These enumerations are going to help you code these functions. You're going to create a function that is called clock enable output, so you're going to select the MCO select and the division. And these enable outputs, you're gonna do the same thing that I did in these lines here in the demo, right? Whereas, not this one, right, is the clock. The speed demo, right?
Yes.
Well, I guess it's a clock demo.
Yeah.
Well, I created a clock demo now. Oh yeah, and this clock demo is where I divided by 4. So you're kind of gonna have to code this into your function using this ones instead of this math.
Okay.
See what I'm saying? You're gonna probably have to clear with this one and then use this. You're gonna have to do a little bit of processing there in your brain to figure that one out. How are we doing with that? We're past that. So we're gonna go for a break, and then when we come back, we're gonna talk about how to actually change the clock speed to a value that we want.